Learning cinematic lighting is difficult. First of all, you need to learn the theory of light in a scene, which typically tells you what 3-point lighting is, how to achieve soft light, maybe the inverse square law, but then the process of learning how to achieve good lighting is simply the matter of trial and error. Second, you need to have a couple of lights to practice those lighting techniques, and they are typically not small, and provided the light has a decent CRI, they are far from being cheap as well. So what do? Well, eventually you would have to reach the state of trial and error and using different lights, but before that, you can understand where to put them to achieve the results that you want. And it all can be done easily, without lifting your butt off a chair. Blender is a free and open source 3D creation suite. It allows for the creation of extremely realistic renders, and one of the reasons for that is the ability to use ray tracing to calculate realistic light behavior. And that's what we need in order to practice different lighting scenarios and to have realistic renders. If you've never touched Blender and you have no idea what I'm talking about right now, you need to watch at least a couple of episodes of Blender Guru Beginner's Donut tutorial. It will teach you how to move things within the 3D viewer, how to scale them and rotate, and other basic stuff. Now, I do not really want to waste my time modeling house and a character to be used in our lighting experiments, so I'm going to show you how to get those for free. Go to theblenderkit.com and install the Blender Kit library onto your Blender. The instruction how to do it will be there. Once you activated this add-on inside of Blender, we can start having fun. First, as usual, delete everything in this scene. Then let's try to find within this Blender Kit library a decent house. All we need to do is to type house and choose the one we like. Drag it and drop it into your 3D viewer. Now let's get inside this house and place a camera somewhere. We also need to position it the way we want to. I remind you that in order to quickly position your camera the same way you are looking right now through your 3D viewport, you need to press Ctrl, Alt, numpad 0. And time has come to choose a character. Unfortunately, the only decent character that is free is this Spider-Man, which is not ideal because his mask will not allow us to create a Rembrandt lighting, but hey, it's better than nothing. Drag him and drop him somewhere in this room. Now we can play with the lighting. I'm going to create one light outside, behind our Spider-Man. This light will be shining through the window. And nothing really happens. This is because we need to switch to a different render engine, to Cycles. And don't forget to enable GPU compute, because the processor is much slower at this. The second light will be inside, pointed at our character. And of course, don't forget to turn off the world brightness so it wouldn't interfere with our experiment. We also are going to create a plane under our character and give it some material. This is done so we can have realistic reflections and light bounces from underneath. Now play with the position of the things in this scene and you'll get something like this. Then I decided to change the color of the backlight, add a lamp, and then a couch in the background to make it a bit more interesting. And this couch is floating a bit. Never mind, now let's have a look at the inverse square law in action. The inverse square law states that the intensity of the light is inversely proportional to the square of the distance between light source and measuring point. What does it mean? It means that if you double the distance between the light and your subject, you need to quadruple the intensity of the light to achieve the same exposure. So let's have a light really close to the character at the intensity of 10 and hit render. This is what we got. Now let's move it back approximately doubling the distance, and now we need to set intensity to 40 to have the same exposure. Due to this rule, notice how light goes from being super bright on the face to a shadow, introducing the whole range of light intensities compared to this when the light is farther from the subject. Now let's delete all lights and create something moody. I'm going to position light directly above her character and increase its size. And here is the render. We can not only position it from above, but also from behind, and this way we'll get us a render like this one. Finally, you can practice your 3-point lighting, where you position one light at a 45-degree angle, the second light is there to lift up the shadows, and the third one opposite to the key one to create some backlighting. This is such a great tool to understand how light's position, its intensity, sizing, and angle is going to affect your image. Once you've played long enough in Blender, you will be able to understand how to light a particular scene and what kind of lights you want to use much easier and much quicker. Thank you for watching, and goodbye.